here we go. Present. This is our product, ScribblScan. And this is our team. I was a project manager and a front-end developer. Also had a little bit hand in AI. Nick, also a project manager and a front-end developer. Eric, full stack developer, crazy on the Bootstrap templates. Sung, video, oh, it seems I've accidentally advanced a slide. Oopsie. Anyway, Sung, our video editor and backend developer. Jasmine, our video editor, who unfortunately couldn't make it today. So sad. And Vignesh, our wonderful instructor, who took so much time out of his days to teach us all some crazy stuff about natural language processing, even though we are in the computer vision course. Anyway, next slide. Here is our product video. Check it out. The prismatic piccolos present ScribblScan. Make digitizing notes and documents a breeze. Humans have been writing with pen and paper for thousands of years. But even though for humans pen and paper is classic, for computers it's tragic. Handwriting inherently possible for traditional algorithms to understand. No two people write the same letter the same way, and even the same person writes the same letter different ways depending on where it is in a text. As such, humans have manually transcribed text from pen and paper to computers for as long as they've existed. But what if that didn't have to be the case? What if all it took was one click to copy text from pen and paper to your computer? To that end, we present ScribblScan. Using ScribblScan is as easy as uploading an image, drawing on a canvas, or snapping a picture with your device's camera. Click Submit and watch your text transform before your eyes. ScribblScan implements an optical character recognition pipeline using a custom line segmentation algorithm and a fine-tuned version of Microsoft's TROCR, or Transformer-Based Optical Character Recognition. We train our model for 3 epochs on the IM Handwriting database, a collection of over 1,000 images of handwritten text documents containing isolated sentences, text lines, and words. We achieve a character error rate of 8.6%, a training loss of 0.23, and an evaluation loss of 0.8. ScribblScan opens up a whole new world of possibilities for those with busy lives. Never manually copy text from pen and paper to your computer ever again. Just scribble, snap, and scan. It's that easy. Let's go. Hope you guys liked it. This background music slaps. Yeah, I got it after searching generic stock music on youtube.com. All right, next slide. So essentially, you already saw what our product was in the video, but essentially it converts images of handwritten text to strings that you can easily process. All you have to do is draw on a canvas, take a picture, or upload a file. Just click Submit, and you can watch your handwriting be transformed before your eyes. All right, Sung, you're up.
For our project, we use a dataset, IM Handwritten Form, which is a dataset containing 1,539 pages of annotated handwritten text in pixel image formats. We initially started off with a custom PyTorch model, but was able to get better results using a vision transformer.
All right, so with our initial model, we were detecting individual characters, but then our next task was to transition to detecting entire sentences, which was a whole problem to tackle. So instead of using a completely custom model, we based our model off of Microsoft's TROCR model, and then we pre-trained that with data from the IAM data set. So a problem we did face was with the model struggling with different styles of handwriting since people write differently. But then with some experimenting, we trained the initial model for 3 epochs. And then we were able to get our training loss down to 0.23, and our validation loss was 0.8, and our error rate was 8.6%. So this is our website. I'm going to screen share real quick. All right, so this is our website that we created with using Flash, Python, HTML, CSS, and JavaScript. We originally decided to use a Bootstrap template, and we actually almost went with the minimal theme itself, but then we decided to opt for custom CSS with just plain Bootstrap to give ourselves more creative freedom. So this is our main page. We have a try it out button where if you click, it takes you to our demo where you can write on it if you want. And we also added options for camera stream and to upload a file. So if I stop my video right now, we can test it out. And you can see my camera feed shows up. Or if you want, we can pick a file. So let's say we want to test It's That Easy. So if we click and we wait for it to detect the text, then it should come out to say, it's that easy. And the other pages we have are tech and metrics, which we use to show the technology, and our metrics for the model, which we presented. And we have our About Us page, which shows all the beautiful people that helped us to create this amazing project.
All right, Eric, thanks for showing off that website. Let me get my screen share back up so we can go through the rest of the presentation.
We utilized a Hugging Face space to hold and run the model, allowing us to run our website on Replit without overtaxing it. And on the next page, we went over, next, yeah. We went over our use cases, which are we were thinking we could use it to digitize written notes, aiding people who have vision impairments, for banks to analyze bank checks, and for teachers to grade student answers.
All right, thank you for listening to our presentation. But that's not all. We've got a little something that we didn't show. If I share the other part of my screen here. Bam. Here we are on my home computer that I don't have access to right now, but I do because remote desktop. We have our thingamajig. So let's test it out. Let's write AI with a mouse. Oh, thinking. AI. How about AI camp? AI corp. Oh no. Got that one wrong. That's so sad. But you might notice up top here, I have this little checkbox that we didn't show on the website earlier. This is a little experimental feature we're doing earlier. If I open my file explorer here, select this one. Bam. You can see the line segmentation here. The cool thing about this algorithm, you're like, oh, cool. What kind of machine learning algorithm did you use to do that? It's not a machine learning algorithm. I spent like 9 hours yesterday going in and manually tweaking this algorithm on my own to detect these lines. And it took a lot of work, but I think it achieves pretty good results. So now let's close this and let's see the results. Yeah, so of course it's experimental because not perfect. You see, you have all this random stuff like the hashtag and the 1934 James. And the reason for that is that if you saw in the line segmentation earlier, it had one extra section at the bottom where it's just like this random junk right here. And the effect of that is when there's not really a lot in the image, we notice that TR-OCR tends to just hallucinate random words. So say I just wrote something like, if I do that. Yeah, it just hallucinates completely random stuff. So if I do like a line there, 0, 0, dot, well, interesting. Anyway, that's the super cool feature. Let me show you another example. This one was a bit of a difficult example for our model. But actually, it does work pretty well. You can see more of the hallucination problem there. Another problem that we came across was, if you notice in the line segmentation, if I upload this again, you notice that sometimes there's little sections from other lines that bleed through to the next line. And the problem with that is it introduces like random apostrophes and stuff into each line. So we didn't end up making an algorithm that like masks parts from other lines out to fix that. But overall, I think pretty cool proof of concept. All right. That's it, I think, for our presentation.